What's up, guys? This is Teddy. Welcome to my YouTube channel. This video, we're going to be talking about linked list. And linked list is something that junior developers need to know. Linked list is something college students need to know. Linked list is something every programmer needs to have an understanding of. And it's sort of nuanced. You actually don't see linked list like hardly at all in modern software development. Like you never see people use a linked list, but the linked list is like the ancestor. It's the dinosaur of the data structure. We still study dinosaurs for a specific reason, to understand where we came from. I'm being corny, but you get what I'm saying. Sometimes we go down into the bedrock of programming so that we can understand things. And understanding how a linked list works is going to be just absolutely crucial to your understanding of how even arrays work, like how everything works, because you have a reference and you can compare them. And I like to call a linked list, this is like a little saying that I like to say, it's an array that's been objectified. And nobody likes to be objectified, but a linked list is an array that has almost been objectified. And I'm going to talk more about that and what that means, but just kind of give you a cool little play on words to just kind of think about. So bad things about arrays. They're fixed, technically. You can still make arrays, like you can roll your own array, and you could make your own array that is dynamic, and there's a list which is technically array which is dynamic, but a traditional array where you're initializing and you're newing up isn't, it's fixed. You can't actually do anything with it. And you can't insert into the middle without it being very expensive. You can insert, and we talked about array assertions and how to actually do them. But as you saw before, inserting into an array is an ON operation. And that is what we don't, that's the middle one. Remember, that's like the Acura, or that's like the Honda. When we really want the Ferrari would be constant. An ON insertion in inserting into an array is it's not ideal. It's not the worst, but it's not ideal. So what we came up with is a linked list. And the good thing about a linked list is that you can insert anywhere into it, and it's dynamic. So you can just, wherever you at the very beginning, and we're going to be inserting at the very start, it's a constant operation. And that's kind of the reason why we even use linked lists, and it's dynamic. It's not fixed, and it's almost like a balloon. Like however much air you put into a balloon, it expands. And a linked list is like that, but with data. Instead of air, there's data inside of the linked list balloon. Not so much the best analogy, but here's a better analogy. An array is a park bench. And I talked about this a little bit beforehand. An array, data is being stored in an array in contiguous places in memory. When people sit on a park bench, like you have to sit in one spot, and then the next person sits in the next spot, and the next person sits in the next spot. But a linked list is almost like people are holding hands, and they can kind of go anywhere in memory, and they can expand, and people can, everybody's holding hands and everything's great. And, it's like that picture. We're all on the beach and we can go anywhere. But a park bench is like, think about how if those people were to be connected somehow and they were to sit on the park bench, they couldn't just go wherever they wanted to. They would have to be sitting in specific places on the park bench. But a linked list is kind of like, you've got places all around in memory, and everything's kind of floating around, but it's logically tied together. And another analogy is like a balloon. Like some people talk about a balloon. And when and we're going to go ahead and flip over to, I'm going to, kind of get a little bit more detail. So this right here is a linked list. And I just went and bought a Wacom tablet, but I'm still not able to use it well, so I'm still just going to use my mouse. But this right here is what logically ties things together. And this right here is called a reference. So you are referencing. And it's important to know the parts of a linked list. I think if you can just kind of get like the parts down, and if you want to write this down, that would be great. So this right here, and I'm going to see if I can't use this Wacom tablet. If I can, bear with me for a second. We're going into the mainframe. Okay, so this is a node. So these little blocks right here, these are called nodes. And nodes are what objectifies arrays. Like these are actual objects. These aren't stored in like an array memory. These are nodes that you actually create. It's almost like you're fashioning your own little data storage buckets. And these reference points are what ties these together. Remember, I gave the analogy of the train and I gave the analogy of people holding hands. And that's what allows you to be able to store, and instead of having an array where things have to be next to each other, this reference point in this node, in this little container or bucket of data, is what gives you the ability to hold data, and the reference is going to be what allows data to be stored all around in memory and what objectifies your data structure, or kind of like an array, but all the, instead of, like I said, instead of being stored side by side, it's all throughout memory. And you also need to know that this is very crucial because nobody ever explained this to me. And it's one of those, like I said, it's like one of those things nobody ever explains. And then you figure it out like a year later and you're like, well, why didn't anybody tell me that? The very last part is going to always be null. If you don't have a null right here, that's going to cause problems, because one of the like foundational parts in being able to actually find stuff in a linked list is for this part to be null. So at the very end, just remember, at the caboose of the train, there always has to be a null. If there's not a null, I don't even think it's like a real linked list. So the null is the caboose. It's like the caboose of the train. And then the head, every linked list is going to have a head. A head is very important because you always have to know where the start of the train is. If you don't know where the start of the train, like what if we just lived in an alternate reality and there was no head, and maybe we just said this was the head, or we just didn't have that, you would never be able to actually keep track of it. It's almost like the length, or it's almost like a pointer to help you logically keep track of where all of this is actually going on. And right now, let's actually let's start small, and we're going to kind of work our way up. Let's go in here, and I'm going to boot up Visual Studio, and let's just create a node. Like, I think that's actually probably the best part to actually start, is just creating a node. Let's not worry so much about the linked list. And I was actually making a video on in-place array operations, so don't mind that. We're going to go in here. Then we're going to call this linked list. Then we're going to create our node. We're going to create a node class. And the node, like I said, is the squares. It's the blocks. It's the containers for your data. And the node always has two parts. You have the actual data, and then you have the thing that points to the next data, or the arrow. So we're going to go in here, and we're going to declare our two parts. Remember, it always has the two parts. It has the actual place the bucket where you actually keep the data, and we're just going to store integers in here just so people don't get confused. You could go in here, you could store strings, you could store whatever you wanted to. It's your data structure. You could store linked list inside of linked list inside of linked list. I don't know why you would do that, but it's possible. And then we're going to have a self-referencing, I don't know the actual term for this, but I think it's called like a self-referencing property. And you don't really see this very often unless you're actually working with linked list. It is kind of like a weird property, I guess you would call it, but just you're gonna see it in linked list. So just all right. So and we're gonna go down here, and we're gonna go console.writeLine. And this part, this isn't crucial down here. We're just going to have this so that this is going to benefit us later on down the road. What's really important is this part right here. And let me see here. I've actually got a node. We're going to go even deeper into nodes. So we've got our data, we've got for, we've got our next. It's going to be the same exact thing. If you look, Data is where we're going to store the actual data. The node is going to be the arrow. And it's going to point to the next bucket, and it's going to point to the next bucket. And if you don't understand exactly what that means, let's just actually go in here and I'm going to show you exactly what this means. So we're going to go, if you want, we can just call this linked list, or I'm just going to put a title up here. So we're going to go linked list, then we're going to go here, and we're going to initialize this node. So we're going to go node, and we're going to call this node A. We're going to call this new node, and we're going to initialize this. So we're going to go here, boom, and we're not going to tie them together yet. We're just going to go in here, and we're going to just create a bunch of nodes, and the IntelliSense is working awesome. So node C is equal to new node. We'll do one more. So go node D is equal to new node. So then we got that. And now let's put some data in here. And you could put any type of data in here. It doesn't need to be any, you could literally put anything. But in our case, we made it so that our nodes can only hold integers, but feel free to go back and change it and put a string in there if you want to. But for right now, I'm just going to do this. So I'm going to go data, then I'm going to go for, and I'm going to change up these numbers. I'm going to make these numbers random so it doesn't like look too similar to the actual reference. So I'm going to go here. I'm going to call this C. I'm going to put some data in here, and we're going to go 9888. Then down here, we're going to go node D, and we're going to go D is equal to data is equal to 222. And basically what I've done is I've gone in here and put data inside of here, just like I did, just logically representing that. That's what I did. Now we need to go into here, and we need to go into our next and make the arrow. This is going to be cool. This is actually very elegant. Like a lot of times in programming, you just look at stuff and you're just like, man, this is so elegant. I can't believe somebody actually came up with this. And then we're going to point it then we point it to the next object. And that's why I say a linked list is like an objectified an array. It's kind of like an array. It's just they're objects, and now they're being tied together because you couldn't do this because an array is stored in a different place in memory. So we're going to go down here. We're going to go B is equal to next is equal to node C. Wait a minute. No, that's right. Okay, so we're going to go node D is equal to next, or node C, or actually we need to do node C, and then we're going to go node D. And they are all logically tied together. And this is actually what's happening inside of a linked list. Whenever you actually create like the actual data structure for a linked list, we've just created the node, but whenever you create a linked list, this is actually kind of like what's going on. And I'll show you what this looks like in memory. So we're going to go clear. We're going to go clear all. Then we're going to go here. And we're just going to look at we're going to add watches to all of our nodes. So we're going to go here. We're going to go add watch. And we just watch. Okay, so it's created an object. If you notice, whenever you see the curly braces, this means you've created an object in memory. And whenever we looked at whenever you have an array looks totally different. It's an array in memory. It's not an object. So we're going to go here, look down here, and then this data is holding, and then it's going to go down to the next one. And it's literally the exact same thing. And we just have a nice little bucket that holds our data, and then it points to the next one. And now it's going to go through and it's going to hook them all up. It's going to form that relationship. It's going to make that arrow. It's going to hook them all up. Now we need to actually create the data structure so that we can iterate through this. Like, this is a cool idea, but just like every other type of we need to actually create an abstract data structure so we can actually be able to do the representation, and we can act on this data, and we can have like a logical place to store this. Remember how I was talking about the abstract data type in the Pokemon? We could just have, I mean, in a crazy universe, we could just have this laying around and we could just have all this out here. But what really makes sense is that we put this inside of an abstract data type so that we can actually do so. We can just have a logical place to keep our tools. Remember, like my dad's toolbox, if I misplaced my dad's tools, he would yell at me. But here it's the same thing. If we just have all our tools strewn about, it doesn't even make sense because everything's so disorganized. So we're going to go in here. We're going to go linked list, and we're just going to create this linked list. Okay, so now let's actually go back and we're going to talk about the actual operations. And there's so many operations that you could do on a linked list. It could make your head spin and you could go through every single thing, but probably the best place to start for a beginner is to insert, to delete, and to iterate. And if you can just kind of logically, if you could just kind of get the visual picture and understand, especially what's going on with the head and with the null, like keep your eye on the head, it sounds kind of weird, keep your eye on the null, and that's going to make a big difference, especially the head. So what we want to do, pretty simple. We're going to go in here. We're going to, let me see here. We're going to create a new shape. And we want to insert at the beginning. We're inserting at the beginning. We're not doing an insert inside. Maybe one day we'll do an insert inside, but let's not get carried away. So assign data to the next field. Okay, so we create a new node. We assign data. Let me see. And this just kind of logically makes sense. So then we'll say this one's going to be 7. Like it doesn't even matter what you put in here. Then we're going to assign the head, and then it's going to point to the next one. So it's going to assign the new field, and that's it. And logically, that just kind of makes sense. So assign data to the next field, make sure that you have the data that you want, and then assign the head, move the head over, and that's pretty much it. And the great thing about this is that's O1. That's like that's the Cadillac, that's the Ferrari, that's what we want. Okay, so let's go back out here, and we will make our insert, and we'll also make a couple helper methods as well too. So we're gonna go prop, we're gonna go node, and you could call this head, you could call this first. I'm gonna call this first. I think it just logically makes more sense. And then we're gonna go in here. I don't even think, we don't need a constructor. All right, and then we need to make a couple, let's do let's go in here. And let's not get carried away. I was going to make a couple helper methods, but let's just stick with what we're doing. So insert first, you could call it insert head, you could call it whatever you want. Then, okay, create the node. What we want to do is create the node. So we go in here, we're going to go new node is equal to the node, because we can't, if we don't have a new node, like how are we actually going to be able to put data in it? So put the data in the node. Put the data in the node. It's almost just like if you think about it, like how would you actually do it? And I know that sounds kind of cheesy and like what a lot of people say, that sometimes you just gotta think about it, but it's actually kind of true. So, okay, so we put the data in the node. Now we need to make the old node the next. So put the old node in next. So we're going to go new node dot next. So we're going to assign the new node as the next node as the first. So we're just going to move over that. We're going to move over that reference, and then make the first, or make the head the new node. And we're going to go down here. We go first is equal to new node. Very simple. And best part of all, this is O1 operation, so it's very fast. All right, so let me see here. Where am I at? Got to get my little visual thing out here. So, okay, now let's talk about delete. So with delete, you make a temporary variable, you assign the new head, and then you pretty much just blow this away. So if we were going to go in here and we were actually just going to delete this head, basically all that's going to happen is it's just going to assign a new head. And you would think that we would clean this up and that we would not leave this here. But a lot of time, and like 99% of the time, you're just going to leave this here. Like, I don't think, especially in an interview situation, I don't think it really makes sense for you to like actually go and delete this. What you really want to do, and like what we're actually just kind of like what we're doing, is we're really just assigning that a new head to it. And this is just going to kind of exist logically. Let me see. This is still going to exist. It's just going to have a different head. And it's going to be like it's logically deleted, similar to the array assertions that we did in the last array. So here, we're going to go down here. We're going to go public. Go node, delete first. Then go down here. Remember, assign the temporary variable. So we go node, we're going to go temp, we're going to go first. So the new temporary variable is going to be the first one. Assign the new head. And then first is going to equal first.next. So now the next head, or the next node, is going to be the head. And then we're going to return the temp. Very, very simple. And possible null reference. Here, because in C#, because the node can be null, it gives that error. Let me see. Then we can go down here, we go into the node, and we should be good to go. All right. And I'm still dereference a possible null reference. Okay. Ever since .NET 6 happened, there's all these null reference errors, and to be honest with you, I really don't understand them, but you can't understand everything, so we just kind of gotta, move on. I swear I don't understand. I wish I knew. If you know, leave a comment down below. Okay, so we're gonna go public. Now, probably one of the most important is we need to learn how to iterate. Iterating is pretty simple. You're gonna assign the current node because you don't want to use the actual node, because you don't want to have the new node as you are iterating through it and you're changing that node. You want to assign a new one. And then you're going to use that new node, or that new reference that you have, and this may sound confusing, to make a while loop, and then you're just gonna basically check if everything's null. So sounds a little confusing, but I'll show you here. So we're gonna go display list, and we're gonna go here, and we're just gonna put like a nice little console write line, and we're gonna say iterating through list, just to kind of let us know what's going on. So go down here, go right here, then we're gonna go node current is equal to first. We're going to assign it because we don't want to iterate through the first. We don't want to actually check the first because we don't want that value to be manipulated. Then we're going to go here. We're going to go is current not equal to null. And this is why this is important, because we want to check if it's null. And once we get to the null, that's what's going to trigger the while loop to stop. Otherwise, it will keep going. So just be cognizant, be aware of that. Otherwise, you could run into issues. So we got current, and this is why I created this display node. So if you want to go back in here, if you don't know what's going on, this is actually on the node, and the node is going to be passed within a console write line. And this is actually why I made this part right here, so that we can just display this very quickly and not have to, and it will actually display it with inside. So most important part, this right here, whenever you see this going on, this means that this is iterating, or this is actually how you iterate through a node. So whenever you see current.next, or see a while loop with a current.next, that is going to be that's going to mean you're iterating within, or if you're doing it within some type of for loop or something. And just for if you're feeling a little I don't know. I don't know what the word would be. If you're feeling a little adventurous, we're going to insert last. So we're going to go int data. Then we're going to go down here. Then we're going to go node current. We're going to assign a current node, and you can see how you actually iterate and you can actually insert into the last part. And it's kind of like a blend of an insertion to the front and also an iteration. And it's going to be, I think it's good because it shows how you can actually do both, how you can actually combine these. So we're going to go current.next is not equal to null. We're going to go down here. We're going to do our iteration. Then once we get to the once we get to the end, what we're going to do is we're going to assign a new node. Then we're going to populate that node with data. So we go in here. So node.data is equal to the data that we want. And then current.next is equal to new node. Let me see. And I think that is right. Okay, so now we've actually built the data structure. What we're going to do is we're going to go into our program.cs file and we're going to actually start using this thing. So let me see. Okay, so let's go ahead. Let's get rid of all this, and we're going to go linked list, and we're going to go. I'm just going to call this linked list is equal to new linked list, and linked. I'm going to show you guys how to insert. So linked list, and we will iterate through each and every one piece by piece. So in this one, we're just going to insert to 1. We're going to go linked list is equal to 2. We're going to insert to 2 in there. Linked list is equal to 3. So we're just going to go 1, 2, 3, and we'll do a 4 for good measures. Then we will do the delete. You see, so we're going to go ahead, then we're going to delete them. So linked list dot delete first. Linked list dot delete. Oh, sorry. Delete first. So we're going to go to delete first. Then we're going to insert last, and we'll do insert last. So linked list dot insert. Let me see. Public void insert last. So we're gonna insert some last. Just do a couple last. Okay, and last but not least, we are going to, after we get done initializing this linked list, and I'm going to make this lowercase. I think this just looks a little bit better lowercase. I'm going to go through here, make this lowercase, make it look more concrete, like it's like an actual object and not a static type or the actual linked list itself. Then I'm going to go to display list. So we went and we created this display list, and I'm just going to go ahead and step through this whole entire thing and add watches as I'm going through it, just to kind of show you guys what this thing looks like. So what's going to happen? And I'm going to blow away all of this. So because there is no constructor in here, we can't actually step inside it. That's kind of the first thing. So, but we can watch the object be created. So let's just go ahead. Let's see what happens. So we've got locals, we've got args. We don't actually have any real nodes first because there's nothing actually being inserted inside of the list. So as of right now, our locals, and let me see if I can get that out of the way. I'm going to add a watch to this. It's always good to add watches to this stuff. So first thing is that we've just created an object, so we can't actually step inside this. If you don't know that, if you're coming from a different language, or if you're coming from, I don't know, maybe you don't know what step into. Step over means we're just going to execute each one of these. Step into means like we're going to go actually inside of this function. So we're going to go ahead, we're going to step inside. And let me bring this over here. I think that'd be a better idea to actually bring this over here so we can kind of see what's going on. So what's going to happen is it's going to create that node, and let's add a watch to this node. I'm going to add a watch so we can kind of see what's going on. So a new node is created, and this is actually a new data structure. So it's kind of getting more complex. You see, the thing about an array is just an array, but these data structures are a little bit more complex. So first thing is what's gonna happen is it's gonna assign our data to, or it's gonna assign whatever we passed into it. In this case, it's a 1 to the data part of this node, of this container, and that is. Let me just go back and just show you guys what this looks like. So basically what's going to happen is we don't actually have the reference yet. And we've just went and we've inserted a 1 into here. And we don't actually have this part yet. Next part is this is actually what's going to happen. This is where it's actually going to assign this next part. So it's going to go down. It's going to put the old node in next, if there is an old node. And then it's going to make the first node the new node. If you can see, you can just watch what happens. So we got here, then there is no next, so it's null. Then it's going to go back. We're going to go insert first. And it's going to do the exact same thing. And if you look right here, you can see our linked list is going to start being populated. So it's going to go new node. And essentially, we're just going to have nodes inside of nodes inside of nodes. It's like nodeception. So it's going to assign that data. It's going to assign the first. And boom. That's the important part. That's where the arrow is actually happening. So it's going to go down. It's going to do the exact same thing. So we're going to step into it. We're going to go new node. Boom. We're going to have new node. But we actually need to, the new node needs to actually go inside of the list. So we're going to put the old node in the next. Boom. That is so elegant and so beautiful. All right. Then first node is going to equal the new node, and we're good to go. And we'll just step through it one more time. Create the node, put the data in the node, put the old node in next, make the first node the new node, and congratulations. And if you see here, we have like nodeception. It's like nodes inside of nodes inside of nodes. Okay, now we're going to delete the first node. So all that's going to happen, it's going to assign a new variable. And we can go here, we can add a watch. So go add watch, then go down here. First is equal to the next node. I call this next dead for some reason. Assign next node. Then return, and we're good to go. It's deleted the first node. Then the same thing's gonna happen. So go down. Now we're going to do an insert last. Insert last is going to be a lot more complicated. You guys don't need to learn this one. I think it's if you're a beginner and you're just trying to learn linked list in order to start learning LeetCode, insert last is going to be something you're going to have to tackle eventually. But for right now, you can just get away with insert and delete. This is just kind of bonus. This is just extra. So first, then we're going to iterate through. It's going to iterate through all of them. It's going to go to the next. Then we don't have any more because we deleted those. Then it's going to go data, current next node. There we go. Then it's going to insert the last. It's going to go to the end. And now we have 3. And then it's going to insert it. Now we can display our list. And the display list is pretty cool too. So we're going to assign the current node as the first node. And if it's not, we're going to display it. Let me see. So iterating through the list, we've got 2 right here. And let me see, I'm trying to figure out if I can, we're in .NET Core, so it's opening up the console, but I'll just iterate through this. And we're iterating through our list. We have successfully iterated through it. And that is pretty much all you guys need to know about linked list. I hope that you guys enjoyed this. If you did, make sure to hit that like button, make sure to hit that subscribe button, and as always, thank you for watching.